All right, now we'll get back to the questions in just a moment, but now we'd like to welcome Tim back to the show. Hi,
Hey,
Tim.
guys.
Good to see
Good
you
to see you
again,
again.
Tim.
All right, welcome back.
Thanks,
All right.
thanks. Great to be here.
And you brought friends.
I did bring friends. And today we're going to talk about pressure. And of course, pressure has a pretty easy equation to it. It's force over area.
Okay.
Now, force can either be a push or a pull. And area is where the force is going down on. Well, the easiest way to do it is everybody take your hand and put it on your thigh.
All right.
And push about half as hard as you can. You feel that? Now,
I do feel it a little bit.
Now stop and just take one finger, put it on the exact same spot, and push the same force down.
You feel it more.
You feel it more
right.
because you've got a smaller area with the same force going down. So that's what pressure is.
Learning
But
something new. This museum guy is great.
every now and again, a blind squirrel finds a nut. We'll turn around. Now we're going to work with. Mr. Z had a really cool bell jar.
He does
He's got
have
an
the
old
old-fashioned
school
ones,
one.
yeah.
And we've got a couple of new ones. Now, the old bell jar, they called it that because you turn around and if you tinged it with your finger, it would sound like a bell. But if you dropped it, it would smash like glass. Where these, if you pick it up, you ting it with your finger, it kind of thumps.
But it
These are much
doesn't
lighter too,
smash.
Tim.
Much lighter, easier to schlep around, no
Yeah.
doubt about that. And actually, we're going to work with kind of the same thing, only we're going to work with a marshmallow right now. We're going to take my marshmallow
guy.
and we're going to put him inside of the bell jar. Now, the bell jar is going to turn around. Oh, let me face him towards the camera. Give
All
him
right, great.
15 minutes of fame.
Good view.
Yeah.
Good view.
Or the start thereof.
Okay.
We'll put that on there, and we're going to turn on the vacuum. When we do, it's going to take all the pressure out of.
So notice he's got a nice rubber O-ring
Yeah,
around
so
there.
he doesn't need all that Vaseline that you have over
the old
there.
ones, yep.
Well, look what's happening to this guy.
Right now, all that pressure is coming out. He doesn't have any air pressure on him, so he's getting a little bit bigger. He's getting a little bit bigger.
Are we going to worry about this guy blowing up on
No,
us?
he's good
No,
to go.
not quite that
Because
big.
marshmallows they're sweet. They're made of sugar and air. Inside, there's all these little air combs, little bubbles of air inside of them.
I see.
He's a pretty good size right now.
He is.
He's doing all right.
Quite a bit.
That's about as big as he's going to get. Now, what do you think will happen when we put the pressure back in?
I would have just assumed he just stayed like he was.
Going to stay like he was?
But
Let's
that's
find
what I
out.
would have thought. Oh, no, poor guy. Oh, my goodness.
He turns into
And
Mr.
there's no
Raisin.
way to get him back.
No, he's pretty much so
He's
done.
cooked now.
You can't do anything about that, but that's all right. Marshmallows are pretty
So
cheap.
why did that happen? Another
All those
Deflategate
little-
thing? Why did that happen?
Well, all those little air bubbles that he talked about burst.
Oh, and it took
yeah.
all that extra weight that he had carried on, he lost it.
And he lost it all. So that's the way that goes.
I guess that makes sense, yeah. Huh?
Now, when you talk about pressure, we're talking about atmospheric pressure. There's a thing called, these are Magdeburg hemispheres.
Okay.
And Otto von Guericke was mayor of Magdeburg. That's in Germany.
Oh, hence the
And that's
name.
1654, and he came up with these
Do you remember that?
hemispheres.
No, yeah.
Yeah, he was around.
I
He
was
was
born a
around.
couple years later.
He was probably next door.
All right.
And what he did is he took these copper hemispheres and he put them together. And you look at it, they don't stick together very well.
Not well at
but
all.
what he did is he turns around.
Can
If you want to
them while
hold those,
do that, Tim? Yep.
Great job. And we'll put the vacuum on and turn around, make sure that it's open. We'll hit it up a little bit with the little vacuum.
Okay, so again, you're sucking out the air.
All the air pressure is out of the inside.
Okay.
And now, turn around and go ahead, you guys grab one end, one grab the other, and give it a pull.
It's not coming apart here.
No.
Not at all.
And it's not going
Not
to.
even a team of horses.
No, exactly, because he put two teams of horses, one on each side
Didn't
to
know
try to
that.
pull this apart, and it stayed together because
That is
of
impressive.
the air pressure. But how do you think we're going to get them back apart?
You'll have to tell me, Tim. I would say put the air back in.
Put the air
There you
pressure back in?
Okay.
If you want to go ahead and...
do the inverse.
You can do it.
Oh, you mean to blow into it?
No, you just don't.
No, just open up the valve.
This little thing
And
here.
this little...
Oh, this little guy. I would have never known that either. Thanks, Mr. Z.
There you go.
Oh, I see. You just had it pinched.
Yeah.
Yeah.
Oh, okay. Ah, there we go.
And
there we
apart
go.
it comes.
Yeah.
So that's,
Yeah, that's
air
pretty
pressure
cool.
on the
Yeah,
outside.
never knew that.
But you know what, we talked earlier about every square inch was about 15 pounds of pressure. So think of how many stamps you could put around all of these. That's the amount of pressure that we would have had to overcome.
Right,
You know,
right.
times
And
15.
And you just take
Yeah.
you did all that work in seconds.
Yeah.
All right.
Nice
and
job.
now, that's easy. Now we've got another atmospheric pressure experiment. And kids, this one looks cool, looks easy, but don't
Don't
try
do
it
it at
at home unless your parents are with you, because they can work with you. What I've got is I've got a little burner, and I've got a soda can, and you notice the football on the outside?
Yeah, you're ready for the
Yeah.
Super Bowl, yeah?
Now
Yeah,
we're
good
all
for you.
over it. And inside I've got a very small amount of water. And I've got the water boiling. And right now that water vapor is filling up inside of the can.
We can actually see.
You can actually,
I
yeah,
can
let's
actually
just
see
put
the
the-
smoke coming out of there, yeah.
Put something black behind it, you can see the vapor coming out.
Okay.
Now what I'm going to do is take the can.
Smart, you're right. That's why you need your parents aside to make sure you things properly. Oh, look at what you did to that guy.
He's strong, huh? Hey.
And
So why did that happen, Tim? Why did that thing collapse so quickly like that once you took it from the heat and put it in the water? Why did that happen?
the heat, well, you had this, all the air that was inside turned around, was forced out, and it was replaced by all the water vapor.
Okay.
And the water vapor took up all that space and held the can against the pressure on the outside. And when you turned around and put it into the cold water, all that water vapor cooled down quickly, turned back into water,
okay.
less space, all the air pressure outside actually crushes it, and it created a vacuum. That's why you pulled all that stuff up.
Okay,
It worked pretty
explain
well.
to us real quick what that means if it creates a vacuum.
It actually
mean it's a vacuum?
turns around and there's a void inside, and it just pulls in. It has to refill the space with the air that's around it, and
That's
there
the term
wasn't
of
air.
vacuum. I got you.
A true vacuum, there would be no air.
Okay.
Okay, that we can't achieve that, but it's lower air, lower pressure.
Okay.
All right, so we've got like one or two more things to do, depending on our time.
All right.
Let's take a look at. We'll do this one real quick. We'll do.
Okay. Whatever you want.
We've got the big bell jar as long as it's out here.
Yeah.
Okay.
We'll turn it on,
Similar to what Mr. Z was doing
and these
earlier.
are all our little turtles.
Oh, is that?
Well,
Did you blow those up yourself?
yeah, they're as
You are
close as I
so
can. This
creative.
turtle's laying down on its back. Oh well.
Dad, I hope
Well, he's sunning himself.
Okay.
He's just doing the bottom.
All right.
Doing the bottom. And right now, what he's doing there, you notice that just like your balloon, all the balloons are getting bigger. The cool part about this is that they're going to get to do the turtle terpsichore in just a second. This is probably
They're
close
gonna
enough. You
do the
notice they've got
turtle what?
terpsichore. You'll see. Watch them.
Okay. They did go topsy-turvy.
Yeah. They did.
Hence the turtle terpsichore.
And there it is. But we've got one more thing. We've got time to do. It'll be
All
cool.
right, great.
And we did the balloons. We've done the marshmallows. Now we're going to do shaving cream.
Yeah, yeah. I hope this doesn't get too messy, Tim.
Oh,
Those
All
was
right,
last.
I'm gonna step over here.
that's why we do it last.
Oh, he does that.
We'll set that in the center. We'll take the bell jar and we'll put it over there. So now you've got all that air pressure that's around it, all that air pressure that's around our, there we go, our shaving cream. Now, what do you think will happen, Ed, when we take that pressure
You know,
away?
I'm always the straight man at all this. I know, Mr. Z, I have no idea, Tim. You're going to have to.
All right, we'll take a look.
Well, what happened to the balloons?
Well, it'll grow and
All right, marshmallow.
fill up or blow up right there. On the,
Let's see, we'll find out.
Like
it's
the
growing,
marshmallow,
like
that's
everything
full of
else.
air, little air bubbles.
Da-da,
Yeah.
da-da,
I wish my vanilla ice cream.
da-da.
Wow, that is really growing. Look at that.
Yeah, it does pretty well. Give it a second. Da-da, 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 da. It's
Look at
coming.
that. It will reach the top of that.
Oh,
yeah.
we'll,
Even
we'll
more
hit
than
the
that.
apex. And now once it gets to all that size, what do you think will happen when we put all that pressure back in?
I think it's going to blow up in our. But it's going to blow up in there, right?
It'll blow up. If it does, it's going to be in there.
That thing's
We'll
not gonna
be
come
fine.
loose.
But everyone, we're just a quiver with anticipation. There
right.
should be arrows in us.
Okay.
That's an archery joke, kids. Never mind. All right. Here we go. We ready?
Ready?
Yeah.
Oh yeah. Oh yeah. Good thing you held that down, Tim.
Yeah,
I know
well,
that- here-
I had to hold it.
What? That made a mess.
It does, but that's all right. It's all encased in there. Wash
Very
it out.
interesting.
It'll
That
be-
was wonderful to watch that. grow.
It's actually a lot of cool stuff with pressure.
But all the same reasoning.
Yeah,
right?
all
You're
the
doing
same
this
reason.
and this guy and the first wound.
all of them. So it's just one of those
Pressure.
things that you get the marshmallow guys.
And you know, it's the same thing with the shaving cream as the marshmallow guys. Like he said, that was the bubbles inside that when he lowered the pressure, expanded, kind of pushed the things out. But now once the air pressure went back in, those bubbles are burst. And this is basically what was inside the can before it came out. You know,
Is there air pressure involved like when it's, scuba divers or people that dive deep, when they come back up, don't they also have to worry about that
well,
sort
it's
of
pressure.
deep pressure?
Every 33 feet you go down is another atmosphere of pressure on you when you're diving. And so
this
the problem
disease, man, in those waters.
Yeah. And the problem is that when you go to those deeper, you go down deeper, more of the gases dissolve into your blood. And that's the problem. You come up too fast, just like you let the pressure out of here.
You could
those-
swallow it up.
Well, yeah. You know, the other thing is when you're diving, you're taught if something goes wrong, you have to surface right away to exhale all the way up. And it seems very different than what you'd want to do, you know. But think about it, every time you go down 33 feet, it's another atmosphere of pressure. So if I held my breath at 33 feet, came to the top, my lungs would double in size.
Oh, hence
See, it's-
the little
yeah,
issue
so
like
that's
that.
why I say
if
it-
you only took the air out of this a little bit, then like the diver coming up slowly, just, if you only take the air out of it a little bit, would it have made that much of a mess? A little bit at a time?
It do it just exponentially is with how much you take out is how much it's going to get bigger, and then it's going to throw
but it's
stuff
more
back.
fun the way you did it.
Oh, yeah, absolutely. absolutely.
And we're into fun here.
Right, right.
All right, well,
That was
we'd
great,
like to
Tim.
thank you,
Thanks.
Tim. We thank Tim for being here tonight. And if you want to see this experiment again or others like it, remember you can always go to our website, homeworkhotline.org, and you can also learn more about the Rochester Museum and Science Center there. Now, we'll be right back in a second.